Welcome to Nerding Out About Software. Today I want to look at the Odin programming language because it's a fascinating one. It frames itself as a C alternative, but focusing more on the joy of programming and ergonomics and being convenient to use rather than languages like Zig, which focus on explicitness in the syntax. It's an interesting approach. It has found some level of adoption, especially in the simulation and game development sphere, but it still feels more like a new kid on the block, despite having been around for about a decade now. It was made by Ginger Bill for the simple reason of not enjoying writing C++, which is a very relatable thing, and let's see what it can do and have a little nerd out about it. If you enjoy this style of video and would like to see more, like, subscribe, and let's get to it. Looking at the core of the language, just the basic syntax, it will be immediately ridiculously familiar to people who have written Go. So if you're used to Golang, this sort of very pleasant C-style syntax is something you already know. You can basically drop in quite a bit of Go code and immediately have it work in Odin, which is beautiful. It's statically typed. You can define what type something is. You can also infer the types. You've got your classic printfs, all of the common things. When you define your functions, in this language they're called procedures, so proc. Everything is pretty simple, pretty immediately easy to grasp, but it also fixes a lot of issues that Golang has. Like, for example, something I sorely miss in Go is explicit mutability. So we have your constants, which we can define, and we also have a very interesting choice that the parameters you pass into a procedure are immutable by default. What does that mean? So it means that if I'm passing X into a procedure, it actually cannot be simply used like this, or redefining X or adjusting the value, because procedure parameters are not mutable. You can go around it by creating a copy, just shadowing it, but in a language where we care about performance and we manually manage our memory and we do all sorts of cool things, we would probably just pass it by pointer. Now, this is another quirk, namely pointer syntax. We're using those little up arrows on Shift 6 rather than stars. You define your pointers, putting it on one side, you dereference, putting it on the other side. It is easy to get adjusted to, but a lot of people, especially online, have been very vocal about not enjoying it. I personally don't care, it's just a symbol, but it is consistent, and that's the important part, so they actually do work quite well. Another thing that it it changes from how Go handles things is error handling. So we have errors as values in Odin, great stuff, but the problem that errors as values have in Go is it's not quite ergonomic handling those errors. So you have your if error not equal nil, if not okay sort of syntax, which is quite verbose, and you pass it everywhere. People write macros for it and end up absolutely mishandling their errors because of it. Now, in Odin, we have beautiful shorthands such as or else. So we don't have to always write an if not equal nil. We can just use or else, or return, or continue. So those most common cases of very simple error handling flow, where you know it's a simple case, every time this fails we do this. Quality of life is there, you've got your syntax sugar, it solves the problem. When it comes to more complicated things, you still have your full errors as values handling, and you can write very custom things. I fully respect that. I think that solving those issues is important. It's something that languages like Go struggle with fixing, because when you're backed by a huge corporation like Google and you have so many people involved, it is difficult to make those decisions on sort of deciding, okay, do we want to include this in the language? Is this not needed? And so on and so forth. In a language that is maintained by a small amount of people, it's easy to drive those changes and work on ergonomics and make things more convenient, because people use it and care about it, rather than having a corporation impose things on it. Lovely, it works. I do quite like that approach. But why is it used in game dev and simulations and all things of that sort? So this is where Odin shines usually the most. It's the data-oriented nature of the language, or more like being well suited to data-oriented things. When you need to do a lot of calculations quickly, it has great tools. So let's look at a very simple example. Let's look at a dead simple particles simulation. Let's make a struct, no classes, simple structs, all clean. We've just position, velocity, and lifetime. And normally you would approach it as like creating an array of structs. That's your array of particles, and that's how you deal with it. In Odin, we have the opposite paradigm available as well. We have a struct of arrays. So it's the same fields, the same particles you would normally deal with, but they are transposed in memory. And if you've ever done matrix multiplication, you know how powerful transposes are for making things quicker. And let's write a very simple function update for your for loops. Have the very nice syntax with ranges. You can do all sorts of very convenient things with them. And you may see there is no main function here. Yes, because we can split things. As long as package main is defined at the top, or package of whatever name is defined at the top, the compiler uses the directories to handle the builds. So instead of writing a build file like a build zig or a cmake file in C++ and C, you can simply put things in one directory, point your compiler at that directory, and it will pick up all the files needed, which is very convenient. It's something that people seem to misunderstand about the language a lot. People seem to say, oh, it has no build system, it is not great for production, but it does have a build system. It's just built into the compiler. You don't have to write a separate file and do it very manually. You might want that level of very manual control for some circumstances, but the build system is built into the language. You can import things from different places, you can do all of that thing, and all you do is simply Odin run and point it at the folder, and that's it. So here we've run a very simple simulation. As you can see, the compilation and the run was very quick. It is not a slow compiling language in my experience. I found that even larger projects compile very quickly. And it's great for doing maths, great for doing this kind of data-oriented things, which is why it shines in simulation, it shines in game development. What else? Well, the language is also manually memory managed, which sounds very scary to people who have only dealt with garbage collector languages. You want manual memory management when you care about performance, such as, again, in simulations and game design. If you're a game developer, you don't want the garbage collector causing stutters in your gameplay when it has to clear the memory. So manual memory management is very useful. But what Odin does is it makes it, again, very ergonomic and very simple to get into. For a lot of circumstances, you don't have to care about allocators specifically. What Odin does is it implicitly injects the allocator if you don't define it. Of course, you can set a compiler flag to disable that or make it not build unless you specify an allocator everywhere very explicitly. So if you want that zig level experience, it's there. But for most use cases, if you don't care that much, you can just use the context that already exists for that procedure, and for specific cases you inject one if you need to. So let's look at a case of, I don't care about allocators, let me just allocate some memory and do stuff. So here we have a simple struct of a greeting with a message and the amount of times it's meant to be shown, and our make greeting function, which returns a pointer to that greeting. So here we will allocate some memory using the new keyword. It's sort of your malloc-ish style allocation. Then for the actual message, we will use strings clone, which also allocates memory. And here we're using tprintf, which is the temporary allocator. So we're using the temporary allocator as opposed to the aprintf, which is the one that persists. So if you need, let's say, a part of your GUI to always have a string allocated and existing, you would use aprintf instead, whereas the temporary allocator will be the one we free later from the context. We can write a little destructor just to get rid of all parts of it together. So in this case, we will be deleting the clone. So for a clone you delete, and for the new we will free. We are just using a pointer to that greeting, and in our main function we just make our greeting and defer a destruction of it. So if you've not seen the defer keyword before, it's something that's common in, for example, Go, but also in Zig. Essentially what it does is it takes that line of code and it will insert it at the end of that scope. So we will immediately write freeing the memory when we've allocated it, so we don't forget about it, but it will actually only be executed at the end of that scope. And also here at the end, we free the temporary allocator. So the temporary allocator is one that you will free periodically as part of your program. So those are those implicit allocations. So you don't pass an allocator to every single function and every single bit of this execution. But what if you want that granular control? Of course you can have it. the language gives you options. It gives you the very convenient way for day-to-day, and when you need it, you can do it more manually. So there's a lot of allocators already provided within the standard library in core mem, but of course you can write your own if you're so inclined, if the performance is really needed for something ridiculously specific. Now, in this case, we will be passing in arena allocator to our procedure and some kind of count. We define an allocator. We just take this arena allocator that we were passed. We use our make function, passing that allocator in. We do our strings clone, passing that allocator in, and that's it. So simply, if you need your specific allocator, make it and pass it. In your main, create that allocator, initialize it, defer getting rid of it. Done. So the simplicity is quite great. It's very ergonomic. Again, the amount of choice you have in the language to use allocators very explicitly or just deal with the implicit context allocator is great, because you can mix and match. It's not that I always have to pass an allocator everywhere, or I always have to rely on the context one. In Odin, you can rely on the context ones and do very simple things where you don't worry about that memory much without thinking about it. And then for the performance critical portion, you can get as granular and as systems level as you need, which is the beauty of the language. The ergonomics allow you to choose when to spend your thinking on something relevant and when to not bother. Another great thing, other than the already moderately batteries included standard library for most things, other than like you don't have an HTTP server, but you do have basic sockets, is that a few commonly used, especially in the gaming sphere, C libraries and graphics libraries are vended in. So you can simply import vendor raylib and it's already there for you. Use it like any kind of part of the standard library. And we can simply go Odin run. And we've got a simple window. Let's look at an actual game example that is playable. So in this case, we've got a moderately simple game that I'll show more about in a second, but again, you can split your files however you want. As long as you call the package main, the compiler will pick it up from that folder. And this particular game is relatively simple, but it is entirely rendered in raylib, so there is no assets, nothing to pull in, everything is drawn. So let's have a little look at it. There we go. As you can see, everything runs really well. Because it's written in Odin, because it's written in a memory managed language, we do not have to worry about a garbage collector causing stutters in our gameplay, so everything will be smooth the whole time. And it's a pleasure to work with, because again, you write it just like it's Go, but you have full control of everything, and raylib is vended in. You don't have to write your own bindings, you don't have to worry about anything. But what if you need something that isn't vended in, like raylib is? Well, we've got full C interoperability with the language, so if we need to pull in anything, we can do that. Looking at a very simple example, we've got for an import libc, which is going to pull in libc from our system. Of course, you can point it at any library you want, but here just showing that it's quite easy to use. So we need to start using C types because we're dealing with C libraries. We do a foreign interface of sorts, defining the function that we want to pull in. But as you see, the procedure definition is using Odin syntax. We're basically just adding a C, but this is all Odin, except this little bit at the end where instead of having a function body, we just say, this procedure has no body in this file, please do not look here, pull it in from wherever we're importing it. And that's basically it. There's not much more philosophy to it. But that's importing C to Odin. There is another thing we can do, which is very interesting. Namely, we can also, because we have the full C interoperability, go the other way. We can export our Odin code as a C ABI compatible library that can be used by other things. The same way that this terminal I'm using, Ghosty, is written in using Zig on the backend that is exported through the C ABI as a library for things like Swift and so on to use for the native GUI on your desktop application rather than writing an Electron app like everyone does these days. We can do the same thing with Odin, so let's have a look at that. So here is a little application I wrote which basically is a markdown renderer. I did it as a simple exercise to show that it works. So a lot of definitions a lot of maths, a lot of string manipulation on the backend in Odin. Then just a simple header file to define all of those types that we needed for our particular things. And all we have to do then is write our front ends. So for Mac, I use SwiftUI, for Windows, C++ and Win32, and for Linux, C and GTK. And it is surprisingly simple to get it to build. So ignoring all the random definitions I've done, it's just 2 steps. We just got the Odin build using the build mode shared to create a shared library, and we export our dilib that can be used by Swift, and then a Swift build that pulls that in your swift.build setup. And that's it. It's surprisingly simple how that works. And running it, we have an application using native SwiftUI, so we've got all of the cool, pretty features that you may or may not love in macOS. And we can write our markdown on the side, get a live preview. Everything runs really quickly because, again, it's written in Odin. Everything is nicely efficient. And that's it. Everything is just there. So we get to write all of our business logic in Odin. We get to write in the nicely ergonomic language with all the performance benefits and data-oriented design shenanigans, but also use native GUIs for whichever platform you're writing for. And I think that's a place where Odin could really shine, because you could be coming from Go, where you've been using a garbage collecting language, but you really like the syntax. You can come to this language with all of the muscle memory of writing code in Go, but adding the memory management to really get that performance out, and still make it compatible with writing native desktop applications rather than wrapping everything in Electron, right? Like people do these days with TypeScript. So tell me what you think. Is this a language you want to try? I think it's very fascinating. I think it's very ergonomic, and I think many people could enjoy it, but also it seems to lack a hype feature. It's genuinely good, but it doesn't have anything that shines more than other languages specifically. It can do everything really well, which to me is a sign of a great language, but also hurts its marketing in a way. Let me know what you think. Like, subscribe if you want more.